In a sequence of integers, the first term is 3. Each new term is obtained by adding 6 to the previous term. In the sequence, the first 4 terms are 3, 9, 15, and 21. Those are the fifth term. All right, so just keep adding 6, I guess. And when you do, you get 27 for that fifth term. What is the average of the fourth, fifth, and sixth term? Well, the first thing we need to do is figure out what is the sixth term, and you will get that by adding 6 to 27, so that's 33. And then if you take the average, it would be 21 plus 27 plus 33 divided by 3, and that average is 27. What is the 20th term? Okay, well, I could keep adding 6, and probably, to be honest, be quicker doing it that way. But let's get a general formula. I think the general formula for the nth term, it doesn't take that long to figure it out, is 3 plus 6 times n minus 1. That's the general formula. So the 20th term would be 3 plus 6 times 20 minus 1. And that is 117. Determine the smallest term that is greater than 1,000. So this general term definitely helps us now again. So we want this to be greater than 1,000. So just solve for this. So 6n minus 1 would be greater than 997. And then n minus 1 would be 997 divided by 6, which is about 166.1. And therefore n would be greater than 167.1. And therefore that smallest n, since n is an integer, would be 168. But we're not done. We've got to figure out the term. The term, therefore, would be 3 plus 6 times 168 minus 1. And that is 1005. Each day, Ella loaded her truck with red shirts and her blue shirts for delivery to 2 stores. At store 1, she dropped off some shirts. At store 2, she dropped off all the remaining shirts. On Monday, she loaded 800 red and 200 blue shirts. At store 1, she dropped off only red shirts. At store 2, 50% of the shirts dropped off were red. How many red shirts were dropped off at store 1? Whew, it's like a riddle. Okay, so store 1, we have a certain number of red shirts. I don't know how many. And then at store 2, and then after she drops it off, let's just say it's X. After she drops it off, the remaining now are, well, the total was 800, so 800 minus X for the red shirts. And the blue shirts are still 200, and nothing's happened with the blue shirts yet. And then finally, when we get to store 2, they're saying that you drop off 50% of all the shirts are red. So that basically means that this 800 minus X, everything's now going to be dropped off, because the way the question is worded is that at store 2, all the remaining shirts are dropped off. So all of that is dropped off. Now what they're saying now is that this 800 minus X is 50%. Basically what that means is that it equals the 200. Both are 50%. Both add up to 100. So both are equal. So that's very straightforward now. That means X is 600. And that answers the question of how many red shirts were dropped off at store 1. On Tuesday, she loaded 5X red shirts and 5X blue shirts. At store 1, she dropped off 40% of the red shirts and no blue shirts. What percentage of the shirts dropped off at store 2 were blue? So Tuesday, we have red shirts 5X and blue shirts 5X. All right. Then what happens? Then initially, that's the initial. And then at store 1, she drops off 40%. So 0.4 times 5X is what she drops off of the red shirts. And that is what? 2X? Okay. So then we get to store 2. And what we have left of the red are 3X. And what we have left of the blue are 5X. Right? So they're saying what percentage of the shirts that are dropped off are blue? Well, the blue is 5X, and the total is 3X plus 5X. So that looks like 5X over 8X. The X's cancel, and we get 5 over 8. Now 5 over 8, they want it as a percentage, so that is going to be 62.5%. On Wednesday, she loaded 3 Y red shirts and Y blue shirts. At store 1, she dropped off some red shirts and no blue shirts. Additionally, she picked up some green shirts. At store 2, she dropped off all remaining shirts, and the numbers of red, green, blue were equal. Of all the shirts she dropped off, determine the percentage that was green. So store 1, and then we'll talk about what is remaining, and then, of course, what is dropped off at store 2, which is what is remaining. So at store 1, we initially dropped off some red shirts. Now, I don't know how many, so I'm just going to say X. Now, what's remaining then is 3Y minus X, because we initially had 3Y for the red. And then for the blue, they're saying it's Y, and for the green, I don't know, so I'm just going to call it Z. Now, at store 2, this is what's dropped off, and they're saying that those are all equal. So 3Y minus X is equal to Y is equal to Z. So we have to figure out what percentage is green. So the green, the Z, represents what percentage of the total. Okay, well, first let's see. As a fraction, that would be Z over 3Y minus X plus Y plus Z. Well, Z is equal to Y, so let's just put that there. And 3Y minus X is also Y. And hold on one second. But here's the thing. Of all the shirts she dropped off, so I think they're looking at the entire total and not what she dropped off at store 2. So this actually should be 3Y, which is the absolute total. That's kind of interesting. Got a little confused there. So this should be, Y is fine because Y is equal to Z for the numerator, but then this should be 3Y, and then this Y, and then the Z, which is Y. So that is how you do it. So that'd be Y over 5Y, and that's just 1 over 5, which is 20%. So it's all of the shirts that she dropped off on Wednesday, so they're including store 1 and store 2 combined. A square slice of bread ABCD has dimensions 30 by 30. The slice of bread has crusts on 3 of its edges, as shown by the bolded sides AB, BC, and CD in figure 1. When the slice is cut into smaller pieces, the smaller pieces are called fair if each piece has the same area and each piece has the same length of crust. In figure 2, M is the midpoint of AD, MN is perpendicular to AD if ABCD is cut along the lines MN, NB, and NC to create the 3 fair pieces. What is the length of MN? Okay, so let's work with that. Let's keep it in the same diagram. So let's label this now, if we can. So since MN is sort of down the middle, that looks to me like 15 and 15 right there, those two. And I'm going to make this line like that. So then if we get the area of the triangle, I'm going to extend this down like this and just call that x. So the area of the triangle would be 1/2 base times height. The base is 30 and the height is x. And that has to be equal to the area of one of those other pieces. So the other piece, first you have this rectangle, and that rectangle is, the dimensions are 15 and 30 minus x, correct? Yeah. And then we have to add to that triangle, this guy, which is 1/2 base times height. The base is 15 and the height is x. And I'm pretty sure that's the math. So this is 15x, so this would be 30 times 15 minus 15x plus 7.5x. So put all the x's on one side, so that'd be 22.5x is equal to 30 times 15, which is 450, and therefore x would be 20. So what do they want? They want the length of MN. So MN is from here to here. So MN is 30 minus x. So that's going to be 10. So 10 is the answer. In figure 3, M is the midpoint of AD, MT is perpendicular to AD, and S lies on MT. If ABCD is cut along the lines MT, TP, TQ, SU, and SV to create 5 fair pieces, what is the length of PQ? Okay, so a little bit different this time. So let's work with this. We're trying to figure out PQ. Okay, so let's keep the diagram in the same screen. Let's label this now. So I'm going to call this guy x, that x. So this will be 30 minus 2x. And so that for PQ, which is what we're trying to figure out, is 30 minus 2x. And then we will label this y, and therefore from v down to c is 30 minus y. And I think that's okay for now. Let's see if we need anything else. Okay, so in this question, instead of areas, I'm going to work with the crusts. And remember, the crusts have the same length. So that means each of these pieces are bounded by the same length of crust. So let me go back to each piece has the same length of crust. That's basically what I was trying to say. So that means that this piece up here, the one that's like this, that's bounded by this dv, right? So that means that is y. But then that's going to be equal to the next piece's crust, which is this and that, which is 30 minus y plus x, right? And then that's got to be equal to the next piece of crust, which is from here to here, and that is 30 minus 2x. And I think that should be sufficient. Y is equal to 30 minus y plus x, which is equal to 30 minus x. Okay, I think hopefully that should be enough to solve. So let's first look at these two. That would give me 2y is equal to 30 plus x. Okay, so that means that, well, it doesn't really matter, but x is 2y minus 30, whichever way you want to do it. And then if we look at y, this guy is equal to this, so y is equal to 30 minus 2x. Sorry, this should have been x. And then plug x here as 2y minus 30, so y is equal to 30 minus 2y minus 30, like that. So y is equal to 30 minus 4y plus 60. So therefore 5y would be equal to 90, and therefore y is 18. So if y is 18, we got to figure out x. So that would mean 36 is equal to 30 plus x. So therefore x is 6. And then finally we can figure out PQ. So it'll be 30 minus 2x, so 30 minus 12, and that's 18. So 18 is the value for PQ. And finally, in figure 3, determine the length of ST. All right, so we're going to label this again. Let's see if I can without making it too confusing. So what do I do here? Okay, well, the first thing, I'm going to draw this line here like that. And the M to S, I will call Z. And then this I'll call Y from S to T. And then T down to the bottom, I will call X. So what are we trying to figure out? ST. So ST is my Y. Okay. Just trying to think about how to set this up here. And then, you know what? I think we can use our values from the previous question. Previous question, we had figured out that PQ was 18, right? Remember? PQ was equal to 18. So that means that PQ is 18. I can just write, well, no. The whole thing is 18, so that would be 9 and 9. Like in terms of P to this point, the middle, and then, okay, that's actually very helpful. I wasn't even thinking about the previous question. And then, since the whole thing is 30, if I subtract that 18 from 30, I get 12. So that means these guys are 6 and 6. Okay, so that's very helpful. Okay, that's very good. And then another thing is that because the length of the crust has to be the same, since that's 18, the length of this crust has to be 18 also, from there to there. And since that's already 6, then that means that guy's got to be 12. And if that's 12, then from U to A will be 18, since the total is 30. Okay, so that is very, very helpful. Okay, so now I can figure this out. Okay, so that shape basically took the entire square and broke it up into 1, 2, 3, 4, 5. 5. Well, I've drawn some blue lines in, but if you didn't look at those blue lines, it was 5 pieces. And since the entire area is 30 by 30, each piece would be 30 by 30 divided by 5, which is 900 divided by 5, which is 180. So each of those pieces has an area of 130. So that triangle, which is PTQ, that would be 1/2 base times height. The base is 18 and the height is x, and that's going to be 180. So that's going to be 9x, and therefore x would be 20. Okay, that's pretty good. And then what's the next step here? And then I guess we can just figure out this shape. I'll show you this shape here. That piece is also 180. So that piece initially is that small rectangle, which is z times 15. Yeah, and then plus the triangle, which is 1/2 base times height. The base is 15, and the height would be 18 minus z. Yeah, and that's 180 also. So this will be 15z, 9 times 15. So 9 times 15 is 135. And then 7.5z is 180. So that means 7.5z is 45. And therefore, z would be 6. Yeah. Okay. So now we just have to figure out, what are we trying to figure out? ST. Okay, so what's ST? ST is y. So ST basically is that entire top to bottom length minus the z minus the x. And that would give me y, which is basically ST. So that's 30 minus z, which is 6, minus 20, and therefore that's 4. So 4 is the answer to this question. A game is played with spinners having 3 equally sized sections numbered with 3 distinct integers. Each game is played between 2 players. Each player spins the spinner once, and the player who spins the highest number is the winner. Using either of the 2 spinners shown, a player could spin 2, 4, or 7, each with a probability of 1/3. And so the spinners would be considered to be the same, and both are labeled 2, 4, 7. Alice spins 5, 9, 11. Ben spins 1, 8, 10. What is the probability that Alice wins? So we have Alice and Ben. And Alice has what, a 5, 9. So 5, 9, and 11. These are the sort of the way of setting this up. And Ben is 1, 8, 10. So this could be 1, 8, 10, 1, 8, 10. And 1, 8, 10. So I'm assuming that it's very simple. Whoever has the larger number wins. Who spins the highest? The player who spins the highest number wins. So who wins? Let's see here. This is A. This is B. This is B. A, B, A. What is the probability that Alice wins? Okay, of the 9 possibilities, Alice wins 1, 2, 3, 4, 5, 6 times. And that in lowest terms, of course, is 2/3. That takes care of part A. Part B, Carol makes the spinner 1, 5, 10. Darsh makes a spinner by choosing 3 distinct integers from 2, 3, 4, 6, 7, 8, 9. Determine how many different spinners Darsh can make so that his probability of winning is greater than Carol's probability of winning. Okay. All right. So I'm going to need a lot of space for this one. So let's see here. So we got Carol and we have Darsh. Carol is set at 1, 5, and 10. Okay. Darsh, however, they are not being as clear. They're saying he's going to choose 3 numbers from this list right here. We got to figure this out. Okay, so Carol, 1, 1, 1, just like before, 5, 5, 5, and 10, 10, 10. Now, Darsh, we don't know. But here's the thing. We want Darsh can... how many spinners can Darsh make so that the probability of winning is greater than Carol's? So we want Darsh's probability to be greater. So since there's 9 total, his probability needs to be 5 over 9. It's got to be greater than or equal to 5 over 9. If that's the case, it would satisfy what the question is asking. Yeah. Okay, so I think there's a couple scenarios. The first scenario is if Darsh, all 3 of his numbers are greater than the 5. So all 3 of Darsh's numbers are greater than 5. So if that's the case, like this number, for example, if it's greater than 5, he'll win, and then win. And it doesn't really matter what happens here. That's going to be a 6 out of 9, so he would win. So that scenario can happen if, let's see, we want all 3 numbers to be greater than 5, so we're going to choose from those 4. So let's see what we can get here. We can get 6, 7, and 8, 6, 7, and 9, 6, 8, and 9, or 7, 8, 9. So these 4 would satisfy the condition that his probability of winning is greater than Carol's. Okay, so very similarly, we do another scenario, 1, 1, 1, 5, 5, 5, and again, try to help him win, Darsh win. And in the second scenario, he would win. If 2 of his numbers are greater than 5, and then 1 number is less than 5. So if two numbers are greater than 5, and you place them here, it'd be win, 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 and then here it would be less than, so it'd be lose, lose, lose. So this is again a 6 out of 9. So we can choose that. Let's see here. We want 2 numbers to be greater than 5. So we're going to choose 2 from here, and then the other number is going to be chosen from here. So we can have a 6, 7, and then something, a 6, 8, and something, a 6, 9, and something, or you can have a 7, 8, something, a 7, 9, something, or you can have an 8, 9, something. Yeah, and for each of these guys, you can put either a 2, 3, or 4, so you have 3 choices for each of those, like that. So it looks like there's 6 of them, and for each of those 6, there's 3, so 6 times 3 is 18. So total would be that 4 and that 18, so 18 plus 4 is 22. And that is the grand total for this question. Aaron makes the spinner 5, 8, 15. Finn makes the spinner 2, 10, 18. Gina makes the spinner XYZ by choosing 3 integers x less than y less than z from this list. Suppose that probability that Finn beats Aaron is P, probability that Aaron beats Gina is Q, and probability that Gina beats Finn is R. Determine how many spinners Gina can make so that P equals Q equals R. Well, let's first try to figure out at least one of these. Finn beats Aaron. So Finn and Aaron, we actually have the numbers, so that should be pretty straightforward. Finn is 2, so we're going to do exactly what we did before to figure out what is the probability. And then Aaron is 5, 8, 15. So 5, 8, 15, 5, 8, 15, and 5, 8, 15. Now let's see, what is the probability that Finn beats Aaron? let's see, what happens with Finn. In the first one, she loses, wins, loses, wins. So she won with the probability 1, 2, 3, 4, 5. So 5 out of the 9. So P is equal to 5 over 9. So that's fairly straightforward there. And then they're saying that this is equal, so that means Q is also equal to 5 over 9. And R is also equal to 5 over 9. Now we have to proceed to the next part of the question, which is trying to figure out, I guess, Gina, because Gina is the one who has XYZ. We don't know, but there's got this big long list here. Okay, so who are we going to compare here? Where's Gina? Gina is only here. She's only in Q, because the first one is Finn and Aaron. No, she's in here also. Okay. So let's just do Aaron and Gina. Aaron and Gina. And we've got Aaron is what? 5, 8, 15. So 5, 5, 5, 8, 8, 8, and 15, 15, 15. And Gina is XYZ. So I don't know what that is. So I'm just going to put XYZ for now. I mean, I don't know what numbers she has chosen from that grand list. Okay. So Aaron wins if what? What is the scenarios here? The way these numbers are set up is that we have only certain possibilities. The first, I think, is that Aaron wins if 15 is greater than X, Y, or Z. Yeah, so if 15 is greater than X, Y, or Z, this would be a win, this would be a win, this would be a win. And then we want the number of W's to be 5, right? Because 5 over 9 is our magic. So that can be achieved with this W and this W. And I think that would be a 5 over 9 win. Yeah. So that would be, I'll call this one the 3, 2, 0. So there's 3 W's here, 2 W's here, and 0 W's here. So that 3, 2, 0 is a 5 over 9 probability. And let's actually try to figure out like a certain type of inequality. So based on everything here, that means that 5 has to be less than X, less than Y. That has to be less than 8. And then that has to be less than Z. That has to be less than 15. So this inequality has to be satisfied. And now let's give some examples. X could be 6. Y could be 7. And the Z could be any of 9, 11, 12, 13, or 14. Yeah. Yeah. Okay. I'm pretty satisfied with that. What's another scenario that you can get 5 out of 9? You will get if this is W, and this is W, and then these 3 are W's. And that I will call a 3, 1, 1 scenario, because this is 3. There's only 1 here and there's 1 there. Just kind of looking at it in groups, I guess. And that also will be 5 over 9. And that inequality will be that X is less than 5, less than 8, less than Y, less than Z, less than 15. And then now let's figure out what would be the values. X could be 1, 3, or 4. Y is less than Z, and it can be chosen from, Y and Z can be chosen from either 9, 11, 12, 13, or 14. Yeah. And then finally, the last one, you can have a W here, 2 W's there, and then 2 W's here. That would indeed be a 5 over 9. And I'll call this one the 2, 2, 1 scenario. And that's a 5 over 9. And this inequality is X is less than 5, less than Y, less than 8, less than 15, less than z. And then this is a scenario where x would be either 1, 3, or 4, y is 6 or 7, and z is either 16, 17, 19, or 20. Okay, so now let's summarize all of this in a table. And there you go. This is the table. So we have case scenario 1, 2, and 3. So this was scenario 1. This 3, 2, 0. This is scenario 2, case 2, and this is case 3. And for each of these are the possibilities. We have the integer, the inequality, which I had mentioned there, there, and there. And then we have the possible values for x, y, and z, right? Which I had also talked about there, there, and there. And just put it in a table there. Okay, so now we have to do the same kind of scenario, but this time for Gina beating Finn. See, this one was Aaron beating Gina. Now we have to do the same thing for Gina beating Finn. And when you do, you get a similar table. And it looks like that. So now you've got two tables and you've got to combine them because, of course, all of this has to be valid. So combining, you'll see that case 2 and case 6 are consistent. And that is when x is either 3 or 4, y is equal to 11, 12, 13, or 14, and z is equal to 11, 1 of 12, 13, or 14. So if we were to make our x, y, z pairs, or triples I should say, it would be as follows. We could have 3, 11, 12, 3, 11, 13, 3, 11, 14, 3, 12, 13, 3, 12, 14, 3, 13, 14. And then we can do the exact same ones with 4. And then all the other numbers would be the same. 11, 12, 11, 13, 11, 14, 12, 13, 12, 14, and 13, 14. So this gives me a total of 12. And then we can also combine case 3 and case 3 and case 5. Those two. And those two would basically mean that x is either 3 or 4, y is 6 or 7, and z is 19 or 20. So that would make 3, 6, 19, 3, 6, 20, 3, 7, 19, 3, 7, 20. And then you can do the same thing with 4, 4, 6, 19, 4, 6, 20, 4, 7, 19, or 4, 7, 20. And that is a total of 8. So then we get that 12 and that 8 to get the grand total of 20.